The purpose of this video is to make the distinction between the probability of a discrete random variable and the probability density of a continuous random variable. So here we have an example of a discrete random variable. It's from our sack with marbles experiment. And what we have here are all the possible outcomes, the number of red marbles. And what we have on the y-axis is the probability of getting that many red marbles. Now let's take a look at something you're all familiar with, the normal distribution. So I've drawn this little dashed line here at 120, and this is a normal distribution with mean equals 100 and standard deviation equals 15. And if I take this line here and pull it across, I get a value of 0.0061. Now the question is that the probability that a randomly selected value from a normal distribution with these parameters, is that the probability that you get a value of 120? And the answer most definitely is no. And the reason for that is that what we're dealing with is a continuous distribution. As a consequence, between any two values, there will always be a third value. So when we think about 120, what we really mean is 120.000000000 all the way to infinity, and the probability of getting exactly that number, counterintuitive though it may be, is 0. So what the heck does this value mean? Well, it means the probability density, so let's see what that's all about. So this is from Kruschke, page 81 of his book. It's actually something I put together, but it's motivated by his figure. And so what I have here are 1,000 points, values of the random variable y going from about 40 to 160. And so we can think about this dashed line at 115. Well, what's the probability that one of these points has a value of 115? Well, again, it's 0 because we're dealing with a continuous random variable. Or another way to think about it, the probability would be 0 that you would have an infinitely small point lying along this infinitely narrow line at 115. What I can do, however, is draw in a line at 114 and a line at 116, those solid lines, and I can calculate the probability of one of those points lying between those two lines. And I can refer to the probability of a point lying between those two vertical solid lines as probability mass. And then what I'm going to do is I'm going to take the probability mass, probability of a point lying between those two vertical lines, and I'm going to divide it by the distance between those two lines as that distance becomes increasingly smaller and approaches 0. And what happens when I divide this mass by this distance, as the distance becomes infinitely smaller, what I get is probability density. So if we come back here, what's our interpretation of 0.0061? It's the probability that an observation will lie between these two lines centered on 120 divided by the distance between those two lines as the distance approaches 0.